Hello students, today's topic of discussion is jigs and fixtures. So basically, to understand jigs and fixture, first of all we will have to define what is jig and what is fixture, right? They both are different terms, but they are somewhat related to each other. Why do we need jigs and fixtures, right? So if we take any manufacturing process, which is available, they all will be basically needing jigs and fixtures to increase productivity, right? So even if we take operations performed on lathe machine, drilling machine, milling machine, each will be basically using jigs and fixtures. That also depend on the number of products you want to produce, whether you want to go for piece production, batch production, or mass production. So if we simply define fixture and jig, before that we'll first concentrate on a particular figure. Let us see that there is a particular block, right? There is a particular block like this. On this particular block we want to suppose make a hole over here, from this side at this particular distance, and from here at this much distance, right? We'll have to hold this particular block in a particular manner so that it will be fixed and will not be able to move or shift, right? So for that we will have to make first of all this particular calculations and support it and clamp it accordingly. So that particular block has been shown over here in this figure. You can see the figure over here, right? So this is nothing but the block which has been supported from the bottom. If you can see, these are nothing but two supporting pins so that it won't be able to tilt from its position. From over here you can see the locating pin, which is this is basically you can consider it in Z direction. This over here is nothing but X direction from which it has been supported, so that you can locate it, sorry, so that you can measure the distance of hole from this particular surface. From here suppose it is at X distance, so that supporting locating pin will be shifted or moved accordingly, right? So that job can move in this particular direction or in this particular direction, and finally in y direction it will be ultimately clamped so that the job will be fixed, and in this particular direction ultimately your drilling tool will be going for making a drill, right? And over here provided is nothing but a jig bush, right? So fixture, what is the definition of fixture? It is nothing but mechanical device designed and used in basically machine shops to enable easy, quick, and consistently accurate locating, which is over here, then supporting from the bottom and clamping the blank from here against the tool for higher productivity and product quality in batch production, right? So ultimately by using this you can increase the productivity, and labor you can use can, I mean, will have not to be a skilled labor. If it is ordinary labor, then also it's fine. Jig, now what is jig? Jig is nothing but fixture only, but it is having additional feature of guiding the tool. So jig bush over here you can see will be used for guiding a tool so that it won't be deviating from its position or axis, right? For this particular thing, designing jigs and fixture, what are the things we will have to keep in mind? But before that, what we will see is, suppose if we are not using jigs and fixtures, what are the problems you will be facing, or what is the tedious process without using jigs and fixture, right? So suppose you can take a disc over here. This is nothing but the disc. From on the disc, suppose you want to make a hole about its axis at this much distance, right? And this particular hole is of particular size, say diameter small d, right? And a large diameter or diameter of a bigger circle is nothing but capital D, right? So the first step you will have to do is cleaning and deburring the disc. We'll have to first of all clean this particular disc and deburr this particular disc out of certain other impurities, right? After that we will have to go for marking and punching. Suppose disc is there, so disc will have to mark, right? And disc we will have to punch. Punching is what? Ultimately that we will have to with the solid punch, or you can say permanent marker, permanent punch, you will have to make a punch over here, mark over here, so that a hole of diameter d can be marked, right? And with the scratcher ultimately you will have to define the distance, define this particular distance, define or draw this particular line with the help of permanent scratcher, right? After that you can go for punching over here, so that hole can be punched and of a specific diameter it can be drilled, right? The next step is mount and fix the blank. Mount and fix the blank on the machine bed or in a vise with proper alignment, support and clamp. As we saw in the previous figure, without using jigs and fixture, what we'll have to do is, suppose on the vise or whatever table is there, suppose this will be the supporting table on which you will have to fix your disc, fix your job, right? The next step will be what? Adjust the tool work position by shifting the job on vise or tool. Basically, suppose if you want to make a hole, right? If we want to make this particular hole, so axis, suppose this is nothing but the drill. So axis of drill and axis of this particular hole has to be properly aligned. Otherwise, it won't be able to make proper hole, or the hole size may vary from its original size. So this particular axis will have to be common of the hole to be made and of the drilling tool, right? Then the next step will be nothing but initiate machining and check for correct tool work position, that we have already made sure. After that you will have to go for machining. After that you can drill a hole in this particular direction with this particular diameter of small d, and finally you will have to inspect and, or you can say, measure the machined feature. You will have to go for inspection whether the hole has been made correctly or not. You will have to define it or measure the dimensions of a hole. So this process, as we can see, is very tedious. If we do not use jigs or fixture, the process becomes very tedious, and ultimately labor you will have to use will have to be very skilled labor, right? At the same time productivity also will be reduced, as it is tedious process, it takes more time, right? Now, purpose of using jigs and fixture. Why do we use jigs and fixtures, right? So the first point, that is to eliminate marking, punching, positioning and alignments, the tedious process that we followed for this making this particular hole without using fixture, right? We'll have to eliminate marking, we'll have to eliminate punching so that pilot drill can be made, right? And we'll have to remove or eliminate the positioning of a drill so that it can be aligned with the hole axis, and ultimately other alignments. Easy, quick and consistently accurate locating, supporting and clamping of the blank in alignment of the cutting tool, right? With the help of locating, supporting and clamping, the job will be fixed, and ultimately you can go for a further particular operation without any tedious process, right? So it should be easy, quick and consistent. It should be repeatable. Each time you will have to use this, you will be using this particular jigs and fixture, so that you can remove that particular tedious process, right? Guidance to the cutting tool like drill and reamer. Cutting tools like drilling tool and reamers has to be guided in a proper manner by means of jig bush ultimately. Next, that is increase in productivity and maintain product quality consistently. So with that, obviously the productivity will be increased and product quality can also be consistent, right? And to reduce operators labor and skill requirement, you can use any particular normal operator also which is who is not skilled. Then to reduce measurement and its cost, also measurement becomes tedious sometimes, as you have made a hole, but whether that hole is of a particular size you want or not, that has to be measured, right? Or that has to be kept in mind, right? So cost also will be increased by using that particular method, right? The next step is nothing but enhancing technological capacity of the machine tools. The productivity ultimately will be increased, that we already discussed. And finally, reduction of overall machining cost and also increase in interchangeability means repeatability. Each time you can go for, suppose whatever tolerances you have provided, each time you will be able to achieve the exact same tolerances. So repeatability is must, and that will be achieved while using jigs and fixture. The next point of discussion is nothing but economic application of jigs and fixtures. Suppose if we have decided to use for a particular process of ours, for a particular product of ours, we have decided to use jigs and fixtures, right? But ultimately we will have to see that whether it is viable or not, whether it is feasible cost wise or not, whether cost of that is ultimately hindering our profit or not, that is basically lowering our profit or increasing our profit. So cost analysis also we will have to make, and that is nothing but economic analysis, whether we will have to see that jigs and fixture we are using are feasible cost wise or not, right? So for that we can see the plot graph shown over here, that of machining cost versus volume of production. To understand that graph, first of all let us understand different modes, right? The first mode, that is in ordinary machines without fixtures, that is over here, is shown by means of W. This is W, which shows what, ordinary machines without using jigs and fixtures. So we are not using jigs and fixture and in ordinary machines like lathe machine, milling machine, drilling machine, etc., right? So you can see the curve over here, machining cost, that is machining cost versus volume of production. So you can see P is nothing but piece production, B is nothing but batch production, and M is nothing but mass production. So you can see the first line, that is without using jigs and fixture, initial cost is lower. The initial cost is lower, but the final cost is higher. Final labor cost is much more higher, because labor you require will be nothing but has to be skilled, right? So labor cost, final labor cost will be higher. If we take the second case, that is in ordinary machine using jigs and fixture, that case is nothing but F, right? That case shown over here is nothing but F, which is nothing but the second scenario in ordinary machines like lathe, milling, drilling, etc., with using jigs and fixtures. So initial cost you can see is somewhat higher. Initial cost is somewhat higher than in the case of W, right? So why initial cost is higher? Because that is nothing but the cost of implementing or improvising the providing the jigs and fixture into the manufacturing process. So it can be increased by some amount of thousands or whatever it is accordingly, right? So initial cost is higher, but the final cost, final labor cost ultimately will be reduced compared to W, right? You can see clearly in the plot. The third scenario over here is nothing but in automated machines, fully automatic or semi-automatic machines with or without using special fixturing. That case over here is shown by A, right? So in that you can see that initial cost of the machine will be much more higher, right? Obviously automatic machines will be more costlier than the ordinary machines, like CNC machine is more costlier than the lathe machine. Vertical milling machine is more costlier than the conventional milling machine, right? So that way the initial cost will be much more higher, that you can see in the graph, but ultimately final cost will be much more lower. The labor cost will be much more lower compared to F and W, right? So this is the scenario. So from this particular plot or graphical representation of economical analysis, what you can derive is, suppose if the volume of production, if the number of products to be produced are less than, or if it falls below this particular line, you can go, or if it is piece production, then you can go for this particular W without using jigs and fixture, because that is viable, right? Now if volume of production falls, or if it is higher than this particular line, more than this particular line, that means if it is mass production, then you can go for this particular automated machines without or with using special fixturing. That will be ultimately feasible, as the cost in this particular case is lowest compared to F and W. And finally, if you want to go for batch production, that is if the volume of production lies in between these two lines, that is batch production, you can go for using jigs and fixture. As you can see, I'll erase everything over here. As you can see in the graph that this is the lowest line for batch production, that is nothing but in ordinary machines using jigs and fixtures. So this is nothing but in economical analysis which says that how to use jigs and fixtures, or whether if you are using jigs and fixture, whether it is feasible for you cost wise or not. Right now, suppose if we have decided that we want to go for jigs and fixtures, we'll have to first design the elements of jigs and fixtures. What are the basic elements or salient elements to be designed while designing jigs and fixture, right? So the first one, that is nothing but, again, let us take the particular block that we have taken example of. This is nothing but the block on which we want to make a hole, right? Over here we want to suppose make a hole from here this at this much distance, and from here at this much distance, right? So that block is shown over here in the figure, right? So the first thing you will have to design is nothing but the base and body or frame with clamping features. You will have to first of all design the base. The base has to be straight. It has to be straight. It is not tilted, or it should be flat. Then the next thing, that is nothing but the locating elements for proper positioning and orientation of the blank. We'll have to locate this particular hole from this distance and from this distance. So for that, ultimately locating pins has to be provided. Supporting pins will be provided on the base, and locating pins has to be provided on the side to vary this particular distance of the hole. Suppose if the hole is to be made over here, right, then locating pins ultimately will be shifted accordingly, right? Then supporting surfaces and base, as we had discussed. Clamping the elements by means of clamps, so that it won't be shifted, it will be ultimately rigid and won't be moved. The next thing, that is tool guiding frame and bushes. Suppose if it is a operation, if there are operations like reaming, drilling or boring, the tool has to be guided in a proper manner. So for that, jig can be provided, jig bush can be provided, so that the drill tool or boring tool or reamer will not be deviated from its axis, right? The next thing, that is indexing plates or systems if necessary only. Indexing, what do we mean by indexing? Suppose there is a plate, right? There is a hole in the center, and with that particular center, we want to make radial holes 1, 2, 3, 4, 5, 6, 7 and 8. Suppose these holes are equispaced, they are at equal distance from each other. So we have made one particular hole. After that, we will index that particular plate so that it will be shifted in this particular direction, and this particular hole will be made. Again, after the performing this particular hole, this plate will be indexed, and ultimately this particular hole will be made. So this is nothing but indexing mechanism. That is only if necessary, right? And finally, auxiliary elements like nut, bolts, fastener, etc. So these are nothing but elements we will have to design if you want to design jigs and fixtures, right? Now, if you go for designing clamping, supporting and locating elements, auxiliary elements and all the other elements, first of all, what are the factors that needs to be considered while designing jigs and fixture? The first one, that is easy, quick and consistently accurate locating of the blank in the jig or fixture in reference to the cutting tool. Whatever blank is there, whatever plate is there, whatever disc is there, that has to be located in a proper, accurately located in a proper manner, and it should be repeatable, it should be easy, right? The next thing, that is providing strong, rigid and stable support to the blank. The base has to be strong, it has to be rigid, right? The next thing, that is quick, strong and rigid clamping of the blank in the jigs or fixture. The clamping should be quick, strong and rigid. It should be quick, it should be easily removable. It is not that the clamping should be such that it takes hours of time, right? Tool guidance, accuracy and safety to the labor, right? And tool guidance should be properly accurate. Easy and quick and uninterrupted loading and unloading. The loading and unloading should be very easy and very quick. It should not be time consuming, it should not be tedious, otherwise there is no use or there is no benefit of using jigs and fixture. Use of minimum and standard parts for making the jigs or fixture. So there are certain standards for using for designing locating pins. How many locating pins should be there, how many supporting pins should be there, how many clamping pins or how many fasteners you will be, auxiliary elements you will be using, right? It is not that you will be using hundreds of parts. Ultimately it will be making your process or operation more complicated, right? So minimum parts and standard parts you will have to use for jigs and fixtures. Adjustable locating for part size variation. If the part is ultimately varied each and every time, then the locating should be adjustable. The locating pin provided over here should be ultimately adjustable. The final thing is chip removal. So chip removal should be easy. It is not that suppose if you are performing drilling operation, if you are performing operation on a lathe machine, the chip removal is not easy, or chips are getting blocked in each and every corner. The chip removal ultimately should be easy. The chips should be easily removed. Easy, quick and accurate indexing system if required, as we discussed earlier. Ergonomics and safety. Ergonomics means it should be feasible to the operator. It should be ultimately comfortable to the operator, and obviously safety of the labor. The next one, that is manufacturability, means ease of manufacture. Suppose if you have designed something but that is very difficult to manufacture, that is not feasible. You should design something which is very easy to manufacture. Durability and maintainability obviously of jigs and fixtures. It will be ultimately used for batch production or mass production, so it should last for long. Then service life of the same, and overall expenses should be minimum, right? Now, what are the major factors or major functions requiring proper design? As we had discussed, there are four topmost major functions. That are, the first one, that is nothing but locating from the sideways, supporting from the base, clamping from the top, clamping of the blank or block or whatever it is. Then finally tool guidance if needed, right? If needed only. Otherwise, these three elements are more than enough. Now, there may be several methods of locating depending upon various things. Depending upon, first of all, job, shape, size and material of the job, machining requirements, which basic operations you are going for, which machine you are choosing, right? And finally cutting tools, type of cutting tools, whether it is single point cutting tool used on lathe machine, whether it is multi-point cutting tool used on, you can say, milling machine or drilling machine, right? And but whenever ultimately what you will have to keep in mind is, whenever you will have to design you will have to design jigs and fixture, you will have to keep in mind the basic rules. So what are the basic rules? That is nothing but fundamental requirements for locating, supporting and clamping principles, right? And for that, ultimately this particular principle is most important principle. That is nothing but 3-2-1 principle. That is nothing but 3-2-1 principle. Suppose whatever element is there in the space, it will be ultimately having 12 degrees of freedom. It will be ultimately having how many degrees of freedom? 12 degrees of freedom means it can shift, it can be moved, it can be rotated in 12 ultimately directions, right? So suppose if we consider this particular block right over here, this particular block over here, it can how 12 degrees of freedom will be achieved. This is nothing but in this particular direction it can move, in this particular direction it can go, right? That is 2 degrees of freedom. In this particular direction it can shift, in this particular direction it can move, right? That is 4 degrees of freedom. In this particular direction it can move, in this particular direction it can move, so those are ultimately 6 degrees of freedom. Now in this particular direction it can rotate in counterclockwise direction. It can also rotate in clockwise direction in this axis, right? That is 8 degrees of freedom. It can rotate in counterclockwise direction in this and clockwise direction in this. It can rotate in counterclockwise direction in this axis and clockwise direction in this axis. So in total there are ultimately 12 degrees of freedom, means 12 ways in which a disc or a particular block or whatever element is there, it can rotate or shift or move, right? So we will have to lock or arrest those 12 degrees of freedom, or arrest those particular 12 motions, right? So for that we will have to locate, support and clamp the workpiece or job or block accordingly, right? So that is why 3-2-1 principle will be ultimately used. So that 3 is what? In the base, if you see the side view, in the base there will be 3 supporting pins which will be supporting the block or job from the base, right? So 3 pins from this particular side. Now this is nothing but the top view. You can see over here there are 3 pins, right? There are 3 pins, supporting pins, from which it has been supported from the base. Now if we see this particular view, locating pins will be 2. There will be 2 locating pins. These locating pins will have to be 2. So that is nothing but 2. From sideways it will be like this particular way, right? And now finally if we talk about clamping pins, right, there will be one particular clamping pin. From the top will be ultimately providing one particular clamping pin, so that it will become 3-2-1 principle. Now mostly all the movements has been arrested. So from the top we have provided this particular force. So 3-2-1 principle, you will be able to arrest 9 degrees of freedom of a workpiece, right? Suppose this is your job, right? So you have ultimately supported from the base like this, right? From sideways you have supported by 2 pins, right? And on from this particular side you have supported by means of this particular pin, right? So ultimately 3 pins over here, 2 pins over here, and 1 pin over here. That shows nothing but 3-2-1 principle. Now your workpiece will be able to move only in this particular direction, in this particular direction, and in this particular direction. So if we arrest these particular 3 movements, workpiece can come out in this particular direction, in this direction, and in this direction. If we arrest these 3 movements, now that is from top, right, from this way ultimately, and this way, all the 12 degrees of freedom will be rotated. So 9 plus 3, that is remaining this one, and this one, will be able to achieve 12 degrees of freedom, which will be ultimately locked, and workpiece or block or job will not be shifted in any particular direction, will not be able to move or shift in any particular directions. So this is the most important principle of 3-2-1, means 3 pins on the bottom, 2 pins on this particular plane, and 1 pin in this particular plane. So 3-2-1 principle of locating, supporting, and clamping, which is very important topic. The next topic we will discuss in the next lecture. Thank you, friends.